Hey friends, I'm Scott Hanselman, and I'm thrilled to be chatting at the conference today. We're going to hear a lot of great cloud content, developer content, DevOps content, IT content, and a lot of it's going to involve the cloud. And I went back and forth about what the title of a good cloud discussion would be, and I've gone back and forth. I thought about how confusing the cloud is. We have to admit, when we're explaining it to customers, when we're explaining it to other developers, it can be very confusing. But for me, I have found the cloud to be a joy. I do work at Microsoft in my day job, but on the side, I have a lot of websites of my own, and I don't have a company to support me. It's just me. It's my little tiny mini Scott company. And in doing that, I need the cloud to be mine. And then sometimes I will go to salespeople or folks that are selling, Azure, and they'll say, let's talk about the cloud. It's really very, very easy. And then they'll show me a slide that looks a lot like this. And that makes me feel afraid and overwhelmed because there's so much choice. And I think to myself, gosh, my system's just running on one computer, or my website's just running on one physical machine, or my website has one VM, and now I have all these choices. And that makes me think about, the old days. And the old days are when, the cloud was just a room that you would go into with someone else's computer here. Maybe if you were lucky, they had color. And then when someone talks to me about containers, we're getting containers, I think about this. There was a time when the cloud was a physical computer that was under my desk, and we just called it hosting. And then I might take that machine and take it elsewhere, put it under someone else's desk. And that was a kind of hosting. But today's cloud is far more sophisticated. It's inside of giant campuses, giant regions like this. This is just one example of what a region as a part of, like, for example, the Azure cloud would look like, which brings me back to this feeling of being confused and worrying about future-proofing my applications and making sure that they're going to run everywhere, and all of my customers, all of my users are going to have a great experience. So one of the ways that I like to reset myself so that this doesn't stress me out is I start at the basics. I start at, like, what do I know? Well, I know that there's storage and then there's compute. So if we look at that through a lens of something like Azure, we are reminded that we have Azure storage at its base. And storage is just other people's hard drives, right? Whether they be spinning ones like this or SSDs. And this is important to remember because back in the old days, I would FTP into a machine, and it had a physical hard drive that looked like this. And I knew where my bits lived. They lived on that hard drive, and I could go and visit that hard drive. I could touch it and feel it vibrate, and I could say, I'm renting that hard drive. But then when we think about this in the context of something like Azure Storage, where I copy a bit up into the cloud and it shows up in many places or multiple places all at the same time, because Azure Storage does both local and geographic redundancy, things start getting really, really interesting. So for example, if I bring up something like the Microsoft Azure Storage Explorer to look at my own personal system, my own personal websites, I can go and open up these storage accounts and I can see all of the bits, for example, for the shows that I do for my podcast. And I know that if I drop a single tiny JPEG into a folder, that is going to be copied into multiple places. Here's a couple from just earlier, a couple of weeks ago. And I know that I take that single 30K JPEG and I drop it into the cloud, and now that's going to be available via a CDN globally for all of the users of my system. And I can no longer visit my hard drive. And that says, okay, that makes me realize, okay, I understand where hard drives live in the cloud right now. They are distributed, and if I lose a byte on one of them, the others are going to take over it. It's like a cloud RAID, right? A redundant array of inexpensive disks. So then if we up level a little bit, we can then think about that in the context of virtual machines, because virtual machines are being lied to. And this is a funny way to think about it. If you have a physical computer, like I have a physical computer, I have a physical computer right here in my desk, that's physical. But if I turned that into a virtual machine, would it know? The virtual machine doesn't know that it's no longer a physical machine. It's being lied to. I could do something like a lift and shift. We hear that term a lot, lift and shift. And I could move that up into the cloud. The machine doesn't care because it's being completely virtualized, right? It doesn't have to think about that because that virtual hard drive is hiding all the complexity from the operating system. And that's really important to remember and to understand. And those virtual machines have virtual disks. So why is that interesting? Well, that's interesting because if, for example, we go into something like disk management in Windows, I'll just do that on my own computer right here. If I go and look at that virtual disk service, we're going to see all of the physical disks on my machine here, my actual desktop. We'll go ahead and see if that'll come up. And we'll note, come on, demos. It's okay. Sometimes demos go wrong. Sometimes they don't. That's okay. Nope. Are you going to embarrass me, my friend? That's all right. We'll try one more time. All right. Looks like that doesn't want to start up. But that's okay. I can create a virtual hard drive or a VHD file. And that VHD file is a container within which other disks can live, file systems can live. And those file systems can be virtualized completely. On top of those file systems exist our virtual machines. So the virtual machine, not only is it being lied to, but the bits that it is sitting on top of, the virtual hard drive, is itself a part of Azure storage. So all of that hardware is being completely virtualized. Why is that interesting? It's interesting because we start to see how the layers fit together. We had that physical hard drive with that physical computer. Now the entire storage system is globally available. It's a giant distributed disk across the entire world. Then we can put on top of that virtual machines that then mount those virtual hard drives, whether they be Linux or Windows hard drives. On top of that, we then build things like app services or websites or containers. And these are two different ways to stop thinking about virtual machines. This is really important to think about when you're future-proofing your applications, because you've got that virtual hard drive, but really what you need is an API agreement. You need an interface that everyone can get along with. And it is that interface that is expressed in containers. So if I were to spin up a container, honestly, I don't think much about the underlying operating system. It might be an Ubuntu container from Canonical, or it might be an Alpine container, or it might be something that's a Windows container. It doesn't really matter because my application is now talking to that agreed upon interface. And this was a big deal for me recently when I went and I converted my Hanselman.com website from a physical machine that was running a very old version of Windows. And I thought to myself, maybe I'll just take Hanselman.com and my podcast that are running on Windows machines, and I'll just lift and shift. That was the easy thing to do. That was the naive thing to do. Because for me, what I thought I wanted was simply virtualization. But virtualization is not a guarantee for future-proofing your application. And again, I'm just one person. I'm going to have to manage the operating system. I'm going to have to keep the thing up to date. I'm going to have to run Windows Update. I'm going to have to go and run apt-get if it's Linux, and keep that container, that virtual machine, alive. And I don't want to just pick it up from under my desk and throw it into a cloud and call that future-proofed. So I needed to start thinking about these interfaces, these agreements, these API agreements. Now, for me, that can be done two different ways. That can be thought about at the operating system level, like a container, where I will work in this container and I will use these Linux APIs. But for me, I used .NET. And in using .NET, I had memory management, storage, threading, networking, all of those different APIs that were available to me. So then when I moved into Azure and I wanted to put something, for example, inside of App Service, we can go into Azure real quick and we'll look at my actual personal Azure. If I look at this app service plan here, the only thing that I know about this app service plan is that it is Linux. I don't even know what flavor of Linux it is. Isn't that interesting? And within it is running 4 websites. My podcast, another show that I do called Azure Friday, and my blog, and then my main brochureware application. If we go into configuration here, we note something really, really interesting. Look at that. You see how it doesn't say operating system, right? It doesn't say Linux, doesn't say Windows. It says, what stack do you want? So we're up-leveling. We're not thinking about disks. We're not thinking about virtual machines. We're thinking about the API agreement. We're thinking about the stack that we want to run on. And it can be any of these stacks, and they're fully supported and fully managed, which is great. So then within .NET itself, I can go and pick specific major versions of .NET. Now, because I was already using .NET for my original application on Windows, that meant that my application, which was over 20 years old, my blog has been running since April of 2002. So it's been over 20 years plus right now, which is really, really interesting. And the fact that it's been running that long meant that I was kind of beholden to .NET, and I was worried that the only way I'd be able to keep my site running was forever on an old Windows virtual machine. But because that API agreement, that base class library, or what .NET calls the BCL, that meant I was able to upgrade my application from .NET on Windows to .NET Core, and then most recently to .NET 6 or 7, which will run cross-platform. So then if we return to my website and we go down into the corner here, we can see that my website on my brochureware site is running on .NET 6.03. And then if we look at my podcast site, we can see it's on a slightly newer version of .NET, but still .NET 6. I can even see the Git commit and the DevOps dashboard right there, which is cool. So I can actually right-click on that. We can click directly on that build. Remember, I'm just one person. It's not a team. There's no team behind Hanselman.com. It's just me and my blog. And I can go there and I can see that in August, I deployed that. So I know exactly what's going on. I can see my test coverage. And that gives me a real sense of power. It gives me a sense that it's going to be okay, that this application is going to be future-proofed because I have the support of this cloud available to me. So if we go back to our slides, we can think about it like this. Now we have a choice between web stuff under app service or web stuff under containers, right? It doesn't really matter. It's both a kind of container because it is abstracting away the virtual machine. When I create my application, do I want to marry myself to the virtual machine world or to the containers world, or just to what we saw was called a stack over there in Azure? Totally up to you, but either one of them gets you farther and farther away from the physical machine. And that's super important to remember. I went actually recently and I took a bunch of Raspberry Pis and I put them in a rack. These are 6 Raspberry Pis in a rack to try to get a sense of what the cloud looked like. And I can actually run Docker on this now. So I have my own little tiny cloud on my desk. And that was a way to start thinking about containers and how I would move my things onto containers inside of Azure. So then I started thinking about what containers are. And if you take a look at something like a container ship, you'll note right off the bat that it's massive, like the cloud. But look how every single container is exactly the same size. That's because they got together and they standardized on that. So then if we go and look at the logo for Docker, which is the company that we tend to think about when we think about containers, we notice that it's a whale. It's actually Moby Dick, because the Docker mascot's name is Moby. And those little containers sitting on top of Moby, who is the container ship. All of that then allows me to go and do something like having my stuff in a container. So then I was able to take my .NET application. I'll just drop down into the command line here for just a brief moment. And then if we go out here, you can see Moby again right there in my directory. I have my Docker file, and that Docker file is allowing me to then run my application anywhere, whether it be the cloud or on Linux or anywhere that containers can be taken. And that also future-proofs me a little bit because it gives me some flexibility in what vendor I decide to use. I've got a little bit more control. I could move it to another vendor that has the ability to run in containers as well. One of the next things that I want to talk about that I find so powerful and exciting about the cloud is that I have more dashboards and more context about what's going on. I mentioned before that it's just me, right? I'm just the only person running Hanselman.com. But if I go and do something like this and show you my big dashboard, this makes me feel like I'm almost like a startup, like a business. Like if you know when you go into like a small business or a startup, they have like a big TV in the lobby when you enter, and they have like pins showing you all the different countries that they're in. That's what I feel like when I have a dashboard. This dashboard was made for me by Azure, and it shows you that my average response time on my site is 12 milliseconds. You can see it looks like I've got some burst of errors that happened here. That's interesting. You can see that there's 273 users that are on the site right now. But what's exciting about a dashboard like this in the context of the cloud is that I can go and click on that failure graph, and it's not just a pretty face. I can see exactly what's going on there. It looks like someone is posting to my website. They're posting to the /index route. That doesn't sound healthy. I'm going to click on that, and it looks like it's happening in production. I can then click on request properties and see where it's coming from. And it looks like it's some kind of a hacker in Hong Kong who's posting directly to my site. And then I can say something like, show me what happened before and after. And we'll see, when did this start and when did it end? What were people doing? And I can see that someone's poking around on my website. That's incredibly powerful because in the past, I would need a team. I would have to open up text files and log files and FTP them and scan them, and it would be a nightmare. When we think about the cloud, it's more than just other people's computers. It's the ability to have some kind of a dashboard like this that makes me feel like a 10x developer, almost like I have a team of 10, when in fact, what's happening here is it's just me plus the power of the cloud, because I was able to move into the cloud by, again, future-proofing my system. That's enabled me to have these dashboards and this context. And it's so much more powerful than these old-style dashboards. I've seen people push back against the cloud and push back against DevOps. And they say, oh, I've already got a dashboard. It's top. I just run top. Or maybe they'll upgrade and they'll say, I've got HTOP. That's way powerful enough. Looking at the single processes on one container or on one machine is not a dashboard. A dashboard really allows you to make business decisions on something like that. And in this case, it made me feel like, I was a startup CEO. So I was moving my application into the cloud, and I really had to start thinking about serving my URLs in a way that didn't involve the customer noticing that I was doing the migration, because a big part of future-proofing is making sure that your application continues to run. It has business continuity. So if we return back to that diagram that we had before of this stack of things, we see that I'm hosting my web stuff here. And in doing that, I need to think about, where do the incoming requests come from? So I went and used a thing called Azure Front Door. Azure Front Door is a kind of a reverse proxy, and it's where all of my incoming traffic is terminated. It is literally, the front door into, Hanselman Hanselman House or Hanselman Manor. And in doing that, it gave me the flexibility to present what I wanted to my users. And that was super useful because if we go to Azure Front Door inside of our Azure portal here, we go and grab the front door and look at the front door designer, you'll notice that I created staging.hanselman.com. So I was able to have, again, as one person, as one engineer, a dev, a test, a staging. So as I was moving my blog into the cloud, moving my websites, all of them into the cloud, the original physical machine was running at hanselman.com. The cloud version was running at staging.hanselman.com, and I slowly moved the traffic over, and then I swapped them. So for a while, 50% of the people were getting the staging traffic, and 50% were getting Hanselman.com on the original. So having that 50-50 split is only possible when you do something like a front door or an ingress proxy like Azure Front Door. Again, something that I wouldn't have been able to do had I just been running this myself. The other thing that I got to think about was where things like functions and serverless would fit in. I run another site that is called Azure Friday. And Azure Friday is a website that basically lets you look at all of my different podcasts. I've got like 700 different episodes of Azure Friday. And I needed to pull those from a database. But the database was hard to use and very confusing. So I had to run a batch file, basically a batch every, gosh, I think I was running it every week, basically. And every week I would go and do that. And it was super challenging because I would have to figure out where am I going to run that? Where's the context of that running? Is it a batch file on my laptop? Is it a cron job running in the cloud somewhere? That's where serverless came in. I created an Azure function, and Azure functions hide all of this as well. So containers and AKS and Kubernetes and orchestrators, they can be entirely hidden behind a serverless function. So I created an Azure Friday serverless function that called that API and then updated my website every time a new episode came out, and it felt like magic. It was amazing. What just happened? It was absolute magic. Serverless means you think about servers less. They still exist though, and this is important. Virtual machines are still there, storage is still there, AKS, Kubernetes, Service Fabric, all of those things, but you don't think about it. I made a function and I stopped thinking about it. And in my mind, this entire stack here collapsed. It collapsed. It's magic. I'll leave you with this really great analogy here. This is wonderful. This is called pizza as a service. And this can be whatever your favorite food is as a service. But let's say that traditionally you want to have some legacy pizza. You need conversation, friends, you need soda, you want some pizza, you're going to need fire, gas, or electricity for the oven. That's on you. That means that's homemade pizza. That's going and living, staying at your house. But maybe you want to get infrastructure, provide some infrastructure. Infrastructure as a service means that you're renting the oven and the gas. That means you get the hardware. So I want a virtual machine. I'm going to rent this, but I have to own everything else. I have to provide the fire. I have to provide the pizza. It's helpful. I don't have to own everything. I don't have on-premises stuff, but it's still not perfect. Then if we expand that to something like containers or platform as a service, more and more is being provided, thereby allowing me to focus on what I'm good at, conversations and friends, or in the context of a business, my business application. The cloud is future-proofing things for me because I know that the company is going to provide the hard stuff and I will provide the things that I'm good at. So if we take pizza as a service all the way to the obvious conclusion here, we can see that I just want to bring conversation. I just want to bring conversation and friends. Wow, I guess that, look at that. Software as a service will even provide the friends for me. Oh my God. Ideally, I don't have to think about future-proofing my life anymore because I just provide my app, I bring it to the cloud. I decide how much support I want, whether it be just infrastructure or whether it goes all the way to functions or software as a service, kind of then cementing the fact that not only is the cloud other people's computers, but it is, in essence, future ready for you if you just pay a little bit of attention. Thanks so much for spending time with me. I hope that this gave you a different way, an unusual way to think about the cloud and a little bit of a tale about my cloud journey. I hope you enjoy all the other great sessions. There's a lot of stuff going on, and I wish all of our presenters the best of luck today. Thanks so much.